Who do you think is going to win this race? Let's pause for a moment. What are the factors we will consider? We will consider physical attributes like their speed, their strength, mental factors like concentration, confidence. If these runners were algorithms, we would consider two things: the running time and the memory space, how long it takes to execute a task, and the memory it uses in the execution process. These are the factors we consider in analyzing the efficiency of an algorithm. And in this video, we are going to talk about the big O notation and how to analyze the efficiency of an algorithm. Stick with me. How fast an algorithm runs is the time complexity of the algorithm, and how much memory the algorithm uses is the space complexity of the algorithm. So what is big O? Big O is a measure of the time complexity of an algorithm. It is a mathematical notation used to describe the worst case scenario of the time complexity of an algorithm. There are 5 measures of big O, and the first is O of 1, or constant time. I have a group of balls here. If I ask you to pick any ball at all from the group, the amount of time it will take you to pick one will remain relatively the same no matter how many balls are in the group. Whether I double or triple the balls, it will always take you relatively the same amount of time to pick just one ball. The second is O of n, linear time. If I arrange the balls in a line and I ask you to count them one by one, the number of balls will determine how long you will take. If I double the number of balls, it will take you double the time. So the time depends on the size of the input. The third is O of n squared, or quadratic time. If each ball had a pair and I asked you to group the balls by pairs, if I doubled the balls, the number of pairs grows exponentially, and so does the time it will take you to group the balls in pairs. The fourth is O of log n, or quadratic time, where your input reduces with every iteration, reducing the time it takes the algorithm to complete its task. If I asked you to pick a green ball from this group, immediately your input size is half, because the number of green balls is half the number of the total balls. And finally, we have O of n factorial, which is the worst possible time, and you must avoid it at all costs. If I ask you to group the 10 balls in every possible order, there are over 3 million possible orders. So when your input size grows, the possible combinations also grows exponentially. So big O helps us determine the efficiency of our algorithms by showing us how long it will take to execute its process based on the input. Now in the next episode, we are going to look at recursion, which is when functions call themselves. If you like this video, click the like button and click the subscribe button. See you in the next episode.